Hello everyone and welcome to this my video on further modelling of non-linear data. My name's Darren from Maths Guru. Yes, if you found me before, hopefully these videos are really helpful. If not, welcome. My job is to try and make maths as easy as I possibly can without sacrificing any of your results. I'm not going to dumb it down so much, I'm just going to teach it really, really well. Now behind me are my learning objectives, and by the end of the lesson we're going to hopefully understand how to linearize square graphs, reciprocal graphs, and logarithmic graphs. Now, if you've been watching my previous videos, you'll probably say, well, hold on a moment, you've already done squared and reciprocal graphs. What are these logarithmic graphs? Oh, it's just another one of the tools you're going to need to use for next year if you are in Australia and you are going to be doing the General Maths Unit 3 and 4. Sounds like a lot, yeah? Well, actually not really, because it's building on the stuff we have done previously. And again, the other videos are on mathsguru.com if you want to go have a look. It's free to sign up, and there is so much stuff on there for you to use. Right, shall we move on? I think so. Now, in previous lessons, we've looked at linearizing data. That's not really that easy to say, by using a CAS. You put the data into your CAS, put it into a list and spreadsheet, do some data and statistics, and piff, puff, poof, out comes your result. Today we're going to look at it by pencil and paper methods as well, because it may well be that the exam that you get at the end of the year for year 11 says to do it by pencil and paper. Highly unlikely, but let's just cover all eventualities. Now you're going to turn around and say, but I haven't been shown that in this course. Nope, but you have been shown it in year 9 and year 10, because all it is looking at straight line graphs. And we know that straight line graphs have the same equation. And that equation is y equals mx plus c. All right, happy with that so far? Right, so if we go into an example, what does it say here? The data in the given table has undergone an x squared transformation. Now, that tells me that it has taken my original x values, and by that, we would normally give an x values and y values. So the ones I've highlighted at the moment, if we were to plot that on a graph, we are going to get the curve that I have just drawn there. Well, I really can't come up with a rule from a curve. It's actually really, really hard, but I can make things easier by doing this transformation stuff, because if I can turn a curve into a straight line, I can find the equation of that straight line. Now, in the exam, they will always tell you what to transform, and in this situation, they said do an x squared transformation. And that means that I've taken all my x values, 0, 1, 2, 3, and 4, and squared them. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And now, rather than plotting x against y, we plot x squared against y. And you can see that here by looking now at my axes. There's x squared against y. And now when we do that, we do, lo and behold, get a straight line. Now, having got that straight line, we can use the maths from year 9 or wherever to help us find the equation of it. And I've got that sort of here, and I'm going to show you using pencil and paper methods. Now, for the moment though, I am going to do something really strange, and I'm going to cross that out, and I'm going to put an x. Because when I started to record this video, I made a silly mistake. I know. Go figure, huh? Not perfect. But the point of it is I'm going to write an x there, and you'll see why in a moment. We know that that is a straight line. And any straight line graph has the equation y equals mx plus c. So I'm going to pretend for the moment that these are my y values and these are my x values. And we're going to see what comes up. Right, m. What does m stand for? Well, m stands for my gradient. M is gradient, so I do rise over run. That means I need to choose 2 points on that line and be able to find the gradient. Well, we do that by drawing a right angle triangle, and we look and say, well, how many units across has it gone? How many units up or down has it gone? Well, we know that this point here starts at 4 and finishes at 9, so we know that it's 5 across. We know that it starts at 10 and finishes at 20, so it's 10 up. So my rise is 10, my run is 5, so my gradient is 2. Easy peasy lemon squeezy. So now we've got y is equal to 2x plus c. How do we find the value of c? Aha! Well, the only way we're going to find the value of c is if we know an x value and a y value. And from that, we literally just choose one from the graph.